In this video, we're going to talk a little bit about software engineering practice. In Chapter 2 of Pressman, he recommends a book on problem solving by George Polya, which was written way back in 1945. And he draws a rather strong analogy, rather convincingly, I think, between the problem-solving steps in the book and the software development process. So, for example, here are 4 broad steps taken from the book on solving a problem. Understand the problem, plan a solution, carry out the solution, and examine the result for accuracy. So, as a software engineer, I can look at these steps, and it's actually fairly obvious to me that they line up nicely with requirements gathering and analysis in step 1, design in step 2, construction in step 3, and verification or testing in step 4. But Pressman breaks this down even further. For example, under understanding the problem, Polya gives the items on the left, and Pressman maps them to the software engineering activities on the right. Namely, finding out who your stakeholders are, gathering your unknowns, seeing if your problem can be broken down into sub-problems, and creating the analysis model, which is more or less a graphical representation of your requirements. Planning a solution is analogous to coming up with a design model. And some of the main questions here involve deciding whether you can reuse existing design patterns or software components, and whether we can break up the requirements into subsets of functionality. But the most important item is perhaps the last. As we're going to see, the question of whether you can create a design model for the software is always going to have a yes answer. However, the effort that various projects will invest in design and the various techniques they use for design is going to depend heavily on the process model that is used. Carrying out the plan is analogous to implementing the solution. One of the questions involved in this is whether the actual code can be traced through the design model all the way back to the requirements. For the second item, I might prefer to line this up with unit test for the various component parts rather than correctness proofs, which are pretty rare for software. Finally, validation of the software. Again, testing each component part of the solution is reminiscent of unit testing. Testing that the software overall meets the initial requirements is known as acceptance testing or validation testing. David Hooker is a software engineer who came up with some basic principles that you should keep in mind when developing software. I'm not going to go over these in detail, but on the face of it, they all look like reasonable, mostly common sense suggestions. Finally, let's take a look at some software development myths. These myths that Pressman gives are quite interesting to me because, at least for some of them, small changes in their wording could potentially turn them into software engineering principles that a lot of people would actually agree with. And that speaks to the second point here, that these myths often have an element or a grain of truth to them. I will leave it up to you to chime in on the discussion boards as to what extent these statements are myths or principles. The first one of these myths we already talked about in a previous video. This may work for manufacturing a simple physical product, but software is focused on design, and you have to bring new developers up to speed on the design of the software. The second myth shown here discounts the importance of requirements gathering and the fact that it is often the most difficult part of software development. The third myth, I think, is understood by anyone who has worked in a real-world project and been told halfway through the implementation that the customer needed a new feature or wanted something to behave in a different way. There are things you can do to help ease the pain of changes in requirements, but they're rarely welcomed by any software developer. We will revisit this particular myth when we talk about agile software development. The fourth myth discounts the importance of maintenance, which, as we've argued, may be more costly in terms of overall effort than all the other parts of the software lifecycle combined. Regarding the first myth on this page, Pressman wants to emphasize that there are things you can do, like unit testing and technical reviews, to assess the quality of the process. In the second myth, Pressman wants to do something similar. He wants to say that working software is not the only deliverable that is important. And this leads into the third myth, since work products other than the code are essentially documentation. I think the way these three myths are worded allow Pressman to defend them fairly easily as myths. However, as we'll see when we start talking about agile development, there are developers who might think that calling these things myths is somewhat misleading. They would say that working software is the primary measure of progress. And they would also argue that the wrong type of process certainly can make you produce too much documentation and certainly can slow you down. In fact, every time I've taught this class in a face-to-face environment, I always get moans on this last so-called myth from students who have developed software and who have been in a position where they were forced to create what they considered to be way too much documentation. And that's it for this module. Thank you for joining me, and I hope you found the material interesting. I'll see you in the next module, and I'll see you online.